Hello, class. Today we're going to be talking about the structure of the Earth. Ooh. So let's do a little bit of an overview to start off. So there's the four basic layers which form the Earth. We have the crust, the mantle, the outer core, and the inner core. And each of these layers is distinct from the others in terms of its composition and its density. As depth increases in the Earth, so we're moving from this way to that way, so does density and temperature. So the first layer we're going to talk about is the outermost rocky layer of the Earth, which is the crust. It's the thinnest of all the layers. It's roughly 40 kilometers deep on average. And it's comprised of two different types of crust. We have continental crust, which is what me and you live on, which is less dense. It's felsic, which just means it's rich in feldspar and quartz. And then we have oceanic crust, which is more dense. It's mafic, which means it's rich in magnesium and iron. And on average, the oceanic crust is thinner than the continental crust. The oceanic crust is roughly 7 kilometers deep on average, and the continental crust can range. It can be as much as 75 kilometers deep on average, which is how we get that 40 kilometer average for the overall crust. Next, we're going to be talking about the mantle. So we're going to talk about the upper portion of the mantle first. And it's referred to collectively as the lithosphere, and it's very rigid. The composition is predominantly mafic, and as we talked about before, that means it's rich in magnesium and iron. And like we said before, as we move down into the mantle, we have an increase in density and an increase in temperature. Temperatures in the upper mantle can range anywhere between 500 and 900 degrees Celsius, which is pretty hot, while temperatures in the lower mantle on the outer core boundary can be almost 400 degrees Celsius. Now, the boundary between the mantle and the crust is called the Mohorovic discontinuity, or the MOHO for short, and the MOHO is characterized by a change in composition and a change in seismic wave velocity. So a little bit more about the mantle. Now the next portion is comprised into two different sections. So underneath the lithosphere we have the asthenosphere, which is sometimes referred to as the plastic mantle. Present in the asthenosphere are superheated rocks which, although are still in the solid state, tend to flow and bend. That's how we get convection currents in the mantle. And beneath that is the stiffer mantle, which comprises the majority of the Earth's total volume and mass. It's over 1,000 miles thick, and it's extremely rigid. So while the temperatures again can get down to somewhere around 4,000 degrees Celsius, the rigid mantle is extremely tough, and it does not move like the asthenosphere. Next, we're going to talk about the outer core. Now, the outer core is very unique in that it is believed to be almost entirely liquid. You know, at such high temperatures, even metals are in a liquid state and flow as water would on the surface. And the outer core is primarily composed of nickel and iron. And here is the outer mantle shown here on this graphic, this orange portion right here. And finally, we have the inner core. Now, while the inner core is also composed of iron and nickel like the outer core, the inner core is believed to be a densely packed sphere. And the inner core is extremely hot, roughly 6,000 degrees Celsius. That's almost 10,000 degrees Fahrenheit. Now, you might assume that because it's so hot, and like we saw in the outer mantle, that the inner mantle would also be liquid. But the inner core would be liquid also. But despite these extreme temperatures, the pressure on the core from the Earth's overlying layers is so great that it's caused the core to become so dense that it can't become a liquid despite the intense heat. Alright, so just wrap up. We talked about the Earth's layers here. We have the crust, which is composed of oceanic and continental crust. We have the upper mantle, which is divided into the asthenosphere, which is the plastic mantle. The lithosphere, which is above the asthenosphere, is composed of the upper portion of the mantle and the crust, and the stiffer mantle beneath that, which is, although very hot, not moving at all. Then we talked about the outer core, which is made of iron and nickel and entirely liquid. Then we talked about the inner core, which is a densely packed sphere, solid, extremely hot, and incredibly, incredibly dense. Alright, so that wraps up our introduction to the layers of the Earth. I would like you to complete the questions that I have posted beneath the video, and I will see you all in class.